Right, so we're going to solve some inequalities today. And this is the first inequality we're going to solve, because we can solve this, we can solve pretty much any of them. And you treat the inequality pretty much like it's an equation. So when you look at it, you obviously look first to see if you have any distributive property, combining like terms, because you always want to simplify each side of the inequality first. So here we have distributive property, and we've done enough of this at this point where we could say that this is going to be 3x plus 3 minus 4x is going to be greater than or equal to negative 5. Now we can combine our like terms, and again, we can see we have a positive 3x and a negative 4x. So we combine those, we get negative 1x plus 3 greater than or equal to negative 5. And yeah, you're right, you don't need to have the negative 1 there, but you still have to have a negative, okay? All right, so we'll continue solving now because we finished simplifying. So now we're going to subtract 3 from both sides of our inequality. And we get negative 1x is going to be greater than or equal to negative 8. Now, this is the point where this is going to vary somewhat from solving an equation. Because now, we need to divide both sides by negative 1. Because we have to get positive x. When I divide or multiply by a negative number to solve an inequality, I have to reverse the direction of the inequality symbol. So now it becomes a less than problem, and it's going to be less than or equal to 8. And our graph, our number line, would look kind of like this. Okay, so again, 8 is our target number. Okay, and x has to be less than or equal to 8. So 8, again, being our target number. Because we have the equal to component, that means that we're going to be filling in the 8, because x is allowed to be 8. And x has to be less than or equal to 8, so that means we're going to be shading in this direction. So this is what our inequality would look like. Okay, now keep that in mind. Just going to kind of draw a quick little version of it over here. Just because I want you to look at the original equation. So if we go back and look at the original equation, all right, and I pick a number that's less than 8. Now think about it. What number is easy to put in that's less than 8? Well, put in 0. If I put in 0 for x, I have 3 times 1, really, because 0 plus 1 is 1. So that's 3 minus 0, so that's 3. And is 3 greater than or equal to negative 5? Well, yeah, it is. So what we solved and what we tried in the beginning, we're going to get the same graph. They're both going to be on the correct side, not the right side, on the correct side of the inequality graph.